Hello everyone, welcome to Physics Online CET classes for PUC first year and second year students. Today we are going to study about the chapter Units and Measurement. You can remember in the previous class we studied brief synopsis regarding units and measurement, and also we solved some conceptual multiple choice questions. So let us continue the chapter Units and Measurement. So today we are going to solve the multiple choice questions based on errors in measurements and significant figures. So before going to solve these multiple choice questions, first we have to know about error in measurement and significant figures clearly. Then only it is easy to attempt all the multiple choice questions. So you can watch all the online theory classes related to units and measurement. Then you can easily understand all the multiple choice questions related to error in measurement and significant figures. So in the previous class we completed the first 22 multiple choice questions based on concepts. Today we can continue the next question, 23rd question, which is based on errors in measurements and significant figures. Yes, the question is the magnitude of difference between individual measurement and the true value of the quantity is called. The magnitude of difference between the individual measurement and true value of the quantity is called. The difference between individual measurement and true value. That means we know the equation actual value minus measured value is equal to what? Actual value minus measured value, that gives absolute error. What it means? Absolute error. What is absolute error? Actual value minus measured value. You can observe the above question. The difference between individual measurement and the true value, that gives absolute error. We know that absolute error is denoted by delta A. Delta A equal to actual value means what? Arithmetic mean. So we can write A mean minus A. So this is called absolute error, and remember absolute error may be positive or that may be negative. Yes, what is the right answer? Absolute error. What is absolute error? The difference between individual measurement and true value, or the difference between actual value and the measured value, that gives absolute error. Then 24th question, instrumental error are due to. Yes, we know that there are two types of errors. Can you remember which are the two types of errors? They are systematic error and random error. Which are the two types of errors? Systematic error and random error. Then this systematic error is divided into three types. Which are those? There are three types in systematic errors, and they are: the first one is instrumental error. Second one is personal error. Third one is natural error. Here the question is instrumental errors are due to. Yes, I will give you first one example for instrumental error. That is zero error in screw gauge as well as in vernier calipers. We already studied in detail about instrumental error. Instrumental errors are due to imperfect designs in the instrument, or there are some defaults in the instrument, or that may be due to zero error in the instrument. You can observe the options here. The first option is imperfect design. Yes, it is right. The second option, zero error in the instrument. Yes, this is also right. So then which is the right option? Both A and B are the right answers. Instrumental errors are due to imperfect design as well as zero error in the measurement. Option C is right. 25th question, systematic errors can be. Yes, systematic errors are due to known causes. If you know the reason behind the error, then we can call it as systematic error. If you don't know the reason behind the error, then we can call it as random error. Here the question is systematic errors can be. Options are positive only, negative only, either positive or negative, none of these. Yes, what is systematic error? Systematic errors are due to known causes. That may be positive or negative. Systematic errors can be positive or that may be negative because you know the reason behind the error. That may be plus or minus. So which is the right answer? Option C, either positive or negative. Option C is right. 26th question. Random error can be eliminated by. We can decrease the random error. Options A. Careful observation. Option B. Eliminating the causes. Option C. Measuring the quantity with more than one instrument. Option D. Taking large number of observations and then their mean value. Yes, which is the right option? Random error can be eliminated by. See here, random error that is due to unknown causes, unknown reason. We don't know actual reason behind random error. Is it clear? If you don't know the reason, then careful observation, eliminating the causes. So these are not the right options because we don't know what is the reason behind the error. Is it clear? So, random errors can be minimized or that can be eliminated only by repeating the observations. For example, if you are going to do an experiment like simple pendulum, we are going to take a pendulum and we are oscillating that pendulum for 20 seconds or for 20 oscillation. We are repeating the same procedure for 3 times. Why we are repeating the same procedure for 3 times or more than 3? Because we want to decrease the error. Sometimes oscillations are not uniform. Sometimes the measurement of the time is not proper. Is it clear? Sometimes the observer counting is not proper. So we don't know the reason behind the random error. So that's why to minimize the random error, we have to do the procedure or the experiment repeatedly. So we know that random errors can be minimized and they can be eliminated by repeating the observations number of times. And at last we can take the arithmetic mean of all the observation. For example, A bar equal to, we can take A1 plus A2 plus A3 so on up to n number of times divided by n. Or we can write A bar equal to, we can use a sigma or summation. So 1 by n take outside, remaining is what? Summation of AI, where I equal to from first observation or first trial to n number of trials. Option D is right. You can see the option D, taking large number of observations and then their mean value. So this is the right answer. Which of the following is the most accurate? Options are 200.0 meter, B 20 into 10 raised to 1 meter, C 2 into 10 raised to 2 meter. Option D is 0.2 into 10 raised to 3 meter. Observe all the options. First option is 200.0 meter. So this means what? 200 meter. Option B, 20 into 10 raised to 1 meter. 20 into 10 raised to 1 means what? 20 into 10, that gives again 200 meter. Option C, you can observe 2 into 10 raised to 2 meter. 2 into 10 raised to 2 means what? 2 into 100. Again we can got the same answer, 200 meter. Then option D is given 0.2 into 10 raised to 3 meter. That means 0.2 into 1000. Again it gives the same answer. But the question is, which of the following is the most accurate answer? Remember, the answer is more accurate only when the greater number of significants are present. Remember, this is very important notation. Greater the number of significant figures, greater the number of significant figures, More accurate is the result or measurement. More accurate is the measurement. Greater the number of significant figures. Number of significant, if it is greater, if it is larger, then accurate is the result or the measurement. Now you have to observe all the four options. Which option is having more significant figures? Remember, in a significant figure, the power of 10 is not considered. Is it clear? The power of 10 are not considered in a significant figure. That may be 10 raised to plus 1 or that may be 10 raised to minus 1. We are not going to consider the powers of 10 in a significant figure. Option B, C and D. Here the numbers are given in terms of power of 10. But we have to count significant figures. In the first answer, how many significant figures are there? There are 3 significant figures. 1, 2 and 3. How many significant figures are there? 3 here. Option B, only there is 1 significant figure. Option C, 1 significant figure. Option D, again there is only 1 significant figure. Which is having the highest significant figure? 200.0 meter. So this is the most accurate result. 200.0 meter. Remember, greater the number of significant figures, more accurate is the measurement. So option A is right. 28th question. If f equal to x square, then the relative error in f is. Yes, we know that relative error is given by the equation. You can remember relative error. It is denoted by delta A is equal to delta A bar divided by A bar. That means delta A bar means mean absolute error. What is delta A bar? Mean absolute error over A bar. A bar means what? Arithmetic mean value. Arithmetic mean. Relative error equal to mean absolute error divided by arithmetic mean. Here the given question is what? F equal to x square. This is the question. So first you can observe this is error in power x square. So this is in terms of, for example, f equal to x square is of the form z equal to x raised to n. So we can call it as error in power. What it is? Error in power. So we know that z equal to x raised to n. So error in power means we can write delta z over z is equal to n into delta x over x. So this is error in power. So what we have to calculate? Relative power. So we can use the equation delta A equal to delta A bar over A bar. Simply I am going to write, instead of z we can write delta f over f is equal to x square. X square means how to write the equation? 2 into delta x over x. Delta f over f equal to 2 into delta x over x. So this is now, it is equivalent to what? Relative error. Observe the options. The first option is 2 delta x over x. Option B delta x square over x. Option C delta x over x. Option D delta x square. So option A is right. 2 into delta x over x. This is relative error in F. Option A is right. 29th question. A student has measured the length of a wire equal to 0.04580 meter. This value of length has number of significant figures equal to. Here we have to find how many significant figures are present in the given number. What is the given number here? 0.04580 meter. This is the given number. So this is what? Length of the wire. How many significant figures are there? Observe the numbers 4, 5, 8, 0. These are the significant figures. because you can remember the rules to determine the number of significant figures. The rule is the zeros left to a non-zero number. Non-zero number is what? 4. The zeros which are present on the left side of the non-zero numbers are not counted. We are not going to count these zeros which are on the left side of the non-zero number. But all other zeros are counted. We can count this number. Is it clear? Which are on the left side we are not going to count. But we can count all other zeros which are on the right side. If a number contains a decimal point, this number is having a decimal point, so we have to follow the rule. What is the rule? The zeros left to a non-zero number are not counted, but all other zeros are counted if a number contains a decimal point. So here in this given number there is a decimal point. We have to consider only zeros on the right side but not on the left side. So now tell me how many significant figures are there? 4, 5, 8, 0. These are the significant figures. 1, 2, 3 and 4. So 4 significant figures are there in the given number. So option B is right. 30th question. The number of significant figures in the numbers 4.8000 into 10 raised to 4 and 48,000.50 are respectively the number of significant figures in the given numbers. Which are the numbers here? The first number is 4.8000 into 10 raised to 4. We are not going to consider the power of 10. Leave it. Remaining is only 4.8000. Remember the rule. The zeros on the left side are not counted. The zeros on the right side are counted if the number has decimal point. So now we can consider all the zeros. So how many significant figures are there? 4, 8, 0, 0, 0. That means there are 5 significant figures in the first number. Second number is what? 48,000.50. 48,000.50. Now tell me how many significant figures are present here. Remember the number has a decimal point 48,000.50. Here the zeros are which are on the left side of non-zero number. And the zeros on the right side of the non-zero number we can consider. So here we can consider all these zeros. Why we can consider here? Because these zeros are on the right side of the non-zero number. Is it clear? These zeros are between non-zeros number 48 and 50. These are non-zero number. Between non-zero number, if zeros are present, then we can consider. So we can write 4, 8, 0, 0, 0, 5, 0. All these zeros we can consider. Now tell me how many significant figures are there? 1, 2, 3, 4, 5, 6, 7. So 7 significant figures are present. So the number of significant figures in the number is 5 and 7. 5 and 7 means option B is right. 31st question. If L equal to 2.331 centimeter, B equal to 2.1 centimeter, then L plus B equal to. Two numbers are given. We have to add these two numbers. This is a significant figure in addition. L plus B equal to. What is the value of L? 2.331 plus B value is 2.1. What is the answer? 2.331 plus 2.1, that gives 4.431 centimeter. 4.431 centimeter. This is the answer. But remember, this is significant figure in addition. You can remember significant figure in addition and subtraction. We have to follow the statement. What is the statement? The final result should contain the same number of decimal places as the number with the least decimal place. Is it clear? The statement is, you can remember, the final result should contain the same number of decimal places as the number with the least decimal place. The given numbers you can observe. The given number L equal to 2.331 centimeter. How many decimal places or how many digits are there after the decimal point? 1, 2, 3. 3 decimal places. Second number B equal to 2.1 centimeter. How many digits are there after the point? Only 1 decimal place. So 1 is least decimal place. So according to significant figures in addition and subtraction, so it states that the final result should contain same number of decimal places as the number with the least decimal places. The final result now we calculated, we have the answer 4.431 centimeter. How many digits are there here? 3 digits. But according to significant figures in addition, we have to consider only least decimal places. So we can modify this answer as here 4.4 centimeter. Why we are going to write only 4.4? Because after point only one decimal point should present, because here you can observe the least decimal place is how much? 1. So we have to consider only one digit after the point. So we have to round off the number. Here 3 is less than 5. If it is less than 5, then the previous number remain constant. So 4.4 centimeter is the right answer. Which is the right option? 4.4 centimeter. Option C is right. 32 question. When two quantities are divided, the relative error in the result is given by. One statement is given here. When two quantities are divided, the relative error in the result is given by. Remember, if I am going to consider two quantities as x and y, when these two quantities are divided, suppose I am going to write z equal to x divided by y, then the relative error in the result is given by. Remember, maximum possible relative error in z, it is given by delta z over z equal to delta x over x plus delta y over y. This is error in division. Error in division. We already studied error in arithmetic operations like addition, subtraction, multiplication and division. Error in division, that is delta z over z equal to delta x over x plus delta y over y. Now delta z over z equal to, you can observe this equation, this is sum of, plus here sum of relative error. Delta x over x is what? Relative error. Delta y over y. Sum of relative error in the individual physical quantity. What it mean? Sum of relative error in individual physical quantity. This is error in division. What is the question? When two quantities are divided, the relative error in the result is given by. Now read the options, which is the right option here. The first one, product of, there is no product here. Sum we have to concentrate. In the option B, they had given quotient, means division, wrong. Difference, it is also wrong. Here option D, the sum of relative error in individual quantities, this is the right option, because in division as well as in multiplication, always we have to use sum, that is plus sign. So option D is right. Yes, 33 question. Error in measurement of radius of a sphere is 1%. Then error in the measurement of volume is. Here error in radius is given 1%. We have to calculate error in the measurement of volume. So volume of a sphere is given by the equation V equal to 4 by 3 pi r cube. This is volume of a sphere. Now here you can observe V equal to 4 by 3 pi r cube means this is error in power. Error in power, that is z equal to x raised to n. In that form we have the equation. So error in power means we can write the equation delta z over z equal to n into delta x over x. So this part you have to remember to calculate error in volume. The given equation is V equal to 4 by 3 pi r cube. Error in volume means we can write delta V over V is equal to 4 by 3 pi r cube. R cube means what? It is of the form x raised to n. I am going to write 3 into delta r over r. Is it clear? This is error in power. Delta V over V equal to 4 by 3 pi. These are the constant value. You can observe 4 by 3 into pi. This is constant. Leave it. Remaining is what? 3 into delta r over r. 3 into delta r over r. Delta V over V equal to 3 into delta r over r is already given. How much? The error in the measurement of radius is given. This is equal to 1%. So in place of delta r over r, we can write 1%. So 3 into 1% will be how much? 3%. So how much error we can get in the measurement of volume? 3% of error is present. 3% means option C is right. 34th question. Find equivalent resistance when R1 equal to 100 plus or minus 3 ohm, R2 equal to 200 plus or minus 4 ohm when connected in series. Yes, when the resistors are connected in series, we have the formula. You can remember resistors when they are connected in series, Rs is equal to R1 plus R2. This is for resistances connected in series. You can remember this formula. Then R1 and R2 values are already given. Right? So now here we can consider error in addition. What is that? Error in addition we can consider here. Because when the resistances are connected in series, we have the formula Rs equal to R1 plus R2. So we have the formula for addition Z equal to X plus Y. Error in addition means delta Z equal to delta X plus delta Y. We can use these equations to find the equivalent resistance. Here in place of delta Z I can write delta R. Delta R equal to delta R1 plus delta R2. In place of Z equal to X plus Y, we can write R equal to R1 plus R2. Right? Now, what is the value of R1 and R2? R1 is 100 ohm. R2 is 200 ohm. Then, delta R1 is how much? 3 ohm. Delta R2 is given 4 ohm. Now substitute all the values. Easily you will get the final answer. Z equal to X plus Y. R equal to R1 plus R2. R equal to, what is the value of R1? 100 plus R2 200. So R equal to how much? 300 ohm. Then delta R equal to delta R1 plus delta R2. Substitute the value. Delta R equal to delta R1 is given 3 plus delta R2 is 4. So delta R equal to 4 plus 3 will be 7 ohm. Then how to write the final answer? R plus or minus delta R is equal to 300 plus or minus 7 ohm. So this is the final answer. Now you can check the options. 300 plus or minus 7 ohm. 300 plus or minus 7 ohm means option A is right answer. 35th question. If 97.52 is divided by 2.54, the correct result in terms of significant figure is. Here you have to consider significant figure in multiplication and division. If you know multiplication and division in significant figure, then you can easily tick the proper answer. So significant figure in division. First I will write its statement. You can remember, you already studied in theory classes. Significant figures in division, because these two numbers are dividing. Significant figures in division. According to significant figures in division, the final result should contain. What it contain? The final result should contain the same number of significant figures. The same number of significant figures as the number with the least significant figure. This statement you have to remember before going to calculate. What is the statement? The final result should contain same number of significant figure as the number with the least significant figure. So which are the given numbers? The first one is 97.52. How many significant figures are present in this given number? There are 4 significant figures. Then the second number is 2.54. Here how many significant figures are there? 3 significant figure. Which is having least significant figure? 2.54. This is having least significant figure. So after dividing these two numbers, the final result should contain only 3 digits. Now let us divide 97.52 over 2.54. What is the final answer? When we divide these two numbers, we will get 38.393700. But according to significant figure in division, the final result should contain only least significant figure, that is only 3 numbers. So we can round off this number 38.9. This is greater than 5. So the previous number is increased by 1. So 38.4 is the final answer. 38.4, that is option A is right. 36th question. The radius of the sphere is given. How much? 5.3 plus 0.1 centimeter. The percentage error in its volume is. The radius is given. We have to find percentage error in volume. Yes, we know that percentage error in volume. I am going to write the radius of the sphere is given. So we can use volume of a sphere. We know that V equal to 4 by 3 pi r cube. Is it clear? This is volume of a sphere. Percentage error in volume. So we can write delta V over V equal to 4 by 3 pi capacities. R cube. R cube means this is error in power. You can observe error in power. Error in power is given by the equation z equal to x raised to n, delta z over z equal to n into delta x over x. So this equation you can remember here. So 4 by 3 pi r cube. R cube means 3 into delta r over r. Here delta v over v equal to 4 by 3 pi. This is a constant. Leave it. Remaining is only 3 into delta r over r. So we can write delta v over v equal to 3 into delta r over r. R is 5.3. Delta r is plus or minus 0.1. So delta r is how much? 0.1 divided by r value is 5.3. So percentage error means multiplied by 100. Delta V over V equal to 3 into 0.1 over 5.3 into 100. So we will get percentage error in its volume. Now observe the options, which is the right answer. 3 into 0.1 over 5 by 3 into 100. Option B is right. 37th question. If the length of the rod A is 3.25 plus or minus 0.01 centimeter. And that of B is 4.19 plus or minus 0.01 centimeter. Then how much rod B is longer than rod A? How much rod B is longer than rod A? What it mean? We have to subtract B with A. So what is the value of A? A value is given 3.25 plus or minus 0.01 centimeter. This is the value of A. The value of B is how much? 4.19 plus or minus 0.01 centimeter. So we have to do subtraction B minus A because the question is how much rod B is longer than rod A. This is error in subtraction. Error in subtraction, you can remember what is the equation? Error in subtraction means we can write z equal to x minus y, delta z equal to delta x plus delta y. For addition as well as for subtraction, we can use this equation. Right? Now, B minus A means here we can write what is the value of B and A. B value is 4.19 minus A value is 3.25. What is the answer? B minus A. That is 4.19 minus 3.25, that gives 0.94 centimeter. Now delta Z, error in the measurement. So we can write delta Z equal to delta X plus delta Y. That means delta Z equal to delta X means what here? Delta A plus delta B. What is the value of delta A? Delta A is 0.01. Delta B is also 0.01. Right? So 0.01 plus 0.01. What is the answer? 0.02 centimeter. This is delta Z value. How to write the answer? See here. Z equal to B minus A. What is the answer? 0.94 centimeter. Delta Z equal to delta A plus delta B. What is the answer? 0.02 centimeter. Then how to write the final answer? 0.94 plus or minus 0.02 centimeter. This is the final answer. 0.94 plus or minus 0.02 centimeter means option C is correct. Remember, most of the students, they are doing silly mistake here. When there is a subtraction in error, remember, when you are going to calculate error, that is delta A, delta B, delta X, delta Y, always remember in addition and subtraction, we have to add the error. Is it clear? We cannot do subtraction for the error. Only we can add the error. But A and B, X and Y, we can add or we can subtract according to the given arithmetic operation. Right? 0.94 plus or minus 0.02 centimeter is the right answer. 38th question. Subtract 0.2 joule from 7.26 joules and express the result with the correct number of significant figures. This is a significant figure in subtraction. Significant figure in subtraction. Yes, which statement you have to remember for subtraction? In the previous problem we already solved. Significant figure in subtraction. In the final result it should contain only the least decimal places. That you can remember. The given numbers are 0.2 joules. This is the first number. Second number is 7.26 joule. First you can observe how many significant figures are there or how many digits are there after the decimal place. 0.2, after this decimal point only one decimal place. In the second number there are two decimal places, 2 and 6. Two decimal places. Then which is the least decimal place here? 0.2 joule. This is having the least decimal place. So after subtracting, the final result should contain least decimal places. So subtract the numbers 0.2 and 7.26. 7.26 minus 0.2 is equal to 7.06 joules. But the final result should contain only one decimal place. So we can write 7.06 can be written as 6 is greater than 5. So the previous number is increased by 1. 7.1 joules. 7.1 joules is the correct number. Option A is right. Multiply 107.88 by 0.610 and express the result with the correct number of significant figure. Now this is significant figure in multiplication. Significant figure in multiplication. For multiplication, we know that the final result should contain least significant figure. Which are the given two numbers? 107.88. It is having totally 5 significant figures. The second number is 0.610. How many significant figures are there here? Totally there are 3 significant figures because this 0 we are not going to consider. Then multiply these two numbers 107.88 into 0.610. So the final answer is 65.8068. But according to the statement significant figure in multiplication, it states that the final result should contain least significant figures. Least significant figure is how much? 3. Only 3 number it should contain. So I am going to round off the number as 65.8 because 0 is less than 5. So the previous number remains constant. 65.8 means option D is correct. 40th question. Mass of body is 210 gram and its density is 7.981 gram per cm cube. What will be its volume with regard to significant figures? Here mass and density is given. We have to calculate volume. So mass m equal to how much? 210 gram. Density is denoted by rho. Rho equal to 7.981 gram per cm cube. We have to calculate volume with regard significant digits. Yes, we know that volume, mass per unit volume gives density. You can remember this equation. Density equal to mass per unit volume. So therefore we want to V equal to m divided by density is denoted by rho. V equal to m divided by rho. So this is significant figure in which arithmetic operation? This is for division, m over rho. This is division operation. For division operation, we know that the final result should contain least significant figure. Mass and densities are given. Mass and density. How many significant figures are there? You can observe. 210. Only 2 significant figure because 0 is not considered. This is not a decimal number. So zeros are not considered. In the next number, density 7.981. How many significant figures are there? 4. So the final result should contain only 2 significant figure because this is having least value. Now let us divide the numbers. V equal to 210 divided by 7.981. What is the answer? 26.3124. But the final result should contain only 2 significant figure. Just round off the number. 26.3. 3 is less than 5. So the previous number remains constant. So 26 centimeter cube. This is the final answer. 26 cm cube. That is option B is right. 41st question. The sum of the numbers 436.32, 227.2 and 0.301 in appropriate significant figure is. We have to add all the numbers. Significant figure in addition. First I am going to write all the 3 numbers. The numbers are 436.32, 227.2, 0.301. This is significant figure in addition. For addition, we know that the final result should contain only least decimal places. First, we can write the decimal places of all the three numbers. In the first number, 436.32, how many decimal places are there? 2 decimal places. In the second number, 227.2, only 1 decimal place. In the last number, again there are 3 decimal place, which is having least decimal place, the second number. So the final result should contain only 1 digit after the decimal point. First, we can add all these 3 numbers. What is the answer? We will get 663.827. 663.821. So here the final result should contain only 1 digit after the point. So I am going to round off. So the final result will be 663.8. Because 2 is less than 5, previous number remains constant. So this is the final answer. 663.8. Option C is right. 42. Mass of a body is 210 gram. Density is 7.981 gram per cm cube. What will be its volume with regard to significant figure? This question we already solved and this is the repeated question. So we can move to the next problem. 43, 44 and 45th questions. So these questions are based on the chapter oscillations and waves. You have to study about those chapters, then only it is easy to understand. So I am going to leave these 3 questions. After studying those chapters, then it is very easy to understand. So I am going to take 46th question. Yes, the percentage error in the measurement if mass and speed are 2% and 3% respectively. The error in kinetic energy obtained by measuring mass and speed will be. See here, error in mass and error in speed is given 2% and 3%. First we can write that error in mass. Error in mass means how to write the equation? Percentage error in mass. So we can write delta m over m into 100. That gives percentage error in mass. It is already given the value. How much? 2%. Similarly, percentage error in speed is also given. That is delta v over v into 100 is equal to how much? 3%. Now we have to calculate error in kinetic energy. Kinetic energy is given by the equation half mv square. So this equation you have to remember to find error in kinetic energy. Is it clear? So we have to find error in kinetic energy. So we can write delta E over E into 100 is equal to 1 by 2 is constant. Leave it. So remaining is what? This is constant 1 by 2. Remaining is mv square. M means what here? Error in mass. Delta m over m into 100 plus v square. V square means what? Error in power. Error in power means how to write the equation. You can remember z equal to x raised to n. That gives z equal to n into delta z equal to n into delta x over x. This formula you can remember. So we can write 2 into delta v over v into 100. Now substitute the values. Error in kinetic energy is equal to delta m over m into 100 is how much? 2% plus 2 into speed value is given 3%. What is the final answer? 2 plus 3 2s are 6. So 8% is error in kinetic energy. Option C is right. 47th question. The maximum error in the measurement of mass and density of a cube are 3% and 1% respectively. Here mass and density errors are given. The maximum error in the measurement of volume will be. We have to find error in the measurement of volume. So here it is already given percentage error in mass. How to write the equation? Delta m over m into 100. It is already given. How much? 3%. Similarly, error in density. Percentage error in density, it is already given. Density, it is denoted by the symbol rho. So, delta rho over rho into 100 is given. That is 1%. Now, we have to calculate percentage error in volume. That means delta V over V into 100 is equal to how much? This is the question. We know that density rho equal to mass per unit volume. Volume equal to what? Mass per density. These equations you can remember here to calculate maximum error in the volume. So I am going to write percentage error in volume. Delta V over V into 100 is equal to mass per density. Mass is delta M over M into 100. Mass per density means what? You can remember error in division. Delta Z over Z equal to delta X over X plus delta Y over Y. So here delta M over M into 100 plus delta V over V into, this is delta rho. Delta rho over rho into 100. Now substitute the value. Delta M over M into 100 is given 3% plus delta rho over rho into 100 is given 1%. So 3 plus 1 will be how much? 4%. So maximum error in the measurement of volume is 4%. Option D is right. 48th question. An atomic clock has an accuracy of 1 part is 10 raised to 10. If two such clocks are operated with precision, then after running for 2500 years, these will record a difference of nearly. They are going to take two atomic clocks, right? So the atomic clock has an accuracy of 1 part is 10 raised to 10. If two such clocks are operated for 2500 years, then these will record a difference of nearly. See here, in 2500 years, the number of seconds will be, first we can calculate about 2005 years. Then later we can calculate the difference. For 2500 years, the number of seconds will be, how many years are there here? 2500 years into 1 year equal to how many days? Accurately we can take 365.25 into 1 day equal to how many hours? Into 1 day equal to 24 hours. 1 hour equal to 60 minutes. 1 minute equal to 60 seconds. Multiply all these values. We will get the answer in terms of second. We will get the answer 788940000. This is the number of seconds for 2500 years. But there is a difference of 10 raised to 10. So therefore, the difference in 2500 years will be, the difference in 2500 years will be, we can take 788940000 divided by 10 raised to 10. It is given 1 part is 10 raised to 10. So we will get the answer 7.8894. So we can write 7 point, round off the number, we will get 89 seconds. Or simply we can write 8 seconds. Round off the number, we will get 8 seconds. So option B is correct. 49th question. The least count of a stopwatch is 0.2 seconds. This is least count. The time of 20 oscillations of a pendulum is measured to be 25 seconds. The percentage error in the measurement of time will be. See here, least count is given how much? 0.2 seconds. Then time period for 20 oscillation. How much time period is? That is 25 seconds. Time period for 20 oscillation is how much? 25 seconds. But we are going to measure that time using a stopwatch. This stopwatch is having 0.2 second least count. See here, 25 second plus or minus 0.2 second. This is the time period. That means T plus or minus delta T. Yes, now we have to calculate percentage error in the measurement of time. How to calculate? See here, least count is how much? 0.2. Percentage error in the measurement of time. So percentage error means we know that delta T over T into 100. Relative error into 100, that gives percentage error. So delta T is 0.2 divided by the time period is 25 into 100. So we will get answer 0.8%. So 0.8% is the maximum error in the measurement of time. 0.8% means option C is right. 50th question. A student measured the diameter of a wire using a screw gauge with a least count of how much? 0.001 centimeter and listed the measurements. The measured value should be recorded as. See here, the least count of the screw gauge is smallest length which can be measured accurately. Remember, we already studied about least count in our theory classes. Least count is what? The smallest length that can be measured accurately using that instrument. As least count is 0.001 centimeter, this is what? Least count. 0.001 centimeter means what? 1 divided by 1000 centimeter. So this measured value should be recorded up to 3 decimal places. See here, in the least count 0.001 centimeter. How many digits are there after the decimal point? 1, 2, 3. 3 decimal places. Right? Using this screw gauge, they are going to take certain numbers. For example, they can take 3 trials. So we know the arithmetic mean. Arithmetic mean equal to what? Sum of all the trials. For example, A1 plus A2 plus A3 divided by 3. After calculating the mean value, the final result should contain how many digits after the point? Only 3 decimal places. So you can observe the options. 5.3200 centimeter, 5.3 centimeter, 5.32 centimeter, 5.320 centimeter. So here how many digits should have present after the point? 3 digits should be present. After decimal point 3 digit means which is the right answer? Option D, because 5.320, 3 digits are present. So option D is right. If theta 1 is equal to 10 plus or minus 0.1 degree Celsius, theta 2 equal to 20 plus or minus 0.4 degree Celsius, then theta 2 minus theta 1 equal to how much? It's very simple question. Theta 1 is given 10 plus or minus 0.1 degree Celsius. Theta 2 is equal to how much? 20 plus or minus 0.4 degree Celsius. What we have to do now? Theta 2 minus theta 1 is equal to theta 2 minus theta 1. This is error in subtraction. Z equal to error in subtraction. Z equal to x minus y. Delta Z equal to delta x plus delta y. You can remember these equations. It will be very easy to calculate theta 2 minus theta 1. Theta 2 minus theta 1 is equal to 20 minus 10 is how much? 10 degrees Celsius. Then error delta z equal to delta x plus delta y. Here we can substitute delta theta 1 plus delta theta 2. Delta theta 1 is 0.1 plus delta theta 2 is 0.4. So 0.5 degrees Celsius. So the final result 10 plus or minus 0.5 degree Celsius. So 10 plus or minus 0.5 degree Celsius means option D is right. Question number 52. If error in the measurement of volume of a sphere is 6%, error in the measurement of its surface area will be. See here, volume is given, we have to calculate area. Right? Error in the measurement of area. Volume of a sphere, see here, delta V over V into 100. It is already given how much? 6%. Or we can write, we know that volume of a sphere means what? 4 by 3 pi r cube. So delta V over V equal to 4 by 3 pi. This is constant, leave it, remaining is what? 3 into delta r over r. Delta V over V in terms of percentage, it is already given 6% is equal to 3 into delta r over r. So delta r over r equal to how much? 3 ones are 3, 3 twos are 6. So we will get delta r over r equal to 2%. Is it clear? So error in radius we got 2%. Error in volume is given 6%. We have to calculate surface area. Remember, surface area is given by S equal to 4 pi r square. This is the formula. 4 pi r square. Right? See here, S equal to 4 pi is constant. So we can write delta S over S equal to 4 pi is constant. We can write 2 into delta R over R. Delta S over S equal to 2 into delta R over R, we got 2%. So we can write delta S over S equal to how much? 2 into 2 will be 4%. Or I will give you a small hint here. Length, area, volume. Volume is given 6%. Area should be 4%. Length should be 2%. Length is having only one side. Area is having two sides. Length into breadth. Volume, length, breadth and height. How many sides? 3 sides. Directly without calculating you can write the answer. If volume is 6%, area should be 4%, length should be or radius should be 2%. So we got error in radius is 2%, area is 4%, so volume is 6%. Now the final answer is how much? 4%. Option C is right. 53 question. A physical quantity is given by x equal to m raised to a, l raised to b, t raised to c. The percentage error in the measurement of m, l and t are alpha, beta and gamma respectively. Then maximum percentage error in the quantity x is. The given equation is x equal to m raised to a, l raised to b, t raised to c. And error in the measurements are given. Errors are how much? Alpha, beta, gamma. These are the error in their measurements. So I am going to write maximum percentage error in quantity of x. In x quantity, we can write delta x over x into 100 is equal to, I am going to write MLT. M raised to a, it is of the form error in power. So I can write a into delta m over m into 100 plus b into delta l over l into 100 plus c into delta t over t into 100. Right? Now, A keep as it is. Delta m over m into 100 is what? Error in mass. It is already given how much? Alpha. delta L over L into 100. It is error in length. It is given beta. Similarly, for time, gamma is given. So, we can write A alpha plus B beta plus C gamma. This is error in the measurement of X. So, A alpha plus B beta plus C gamma means option A is correct. 54th question. If Z equal to A raised to 4, B raised to 1 by 3 divided by C into D raised to 3 by 2. What is the equation here? Z equal to A raised to 4, B raised to 1 by 3 over C into D raised to 3 by 2. Then relative error in Z, delta Z over Z is equal to, yes, we already solved some problems regarding relative error in the given physical quantity. You can remember. Here this is error in power. Error in power. You can remember error in power is given by Z equal to X raised to N. Delta Z over Z equal to N into delta X over X. So this equation you can remember here. Now here I can write delta Z over Z equal to A raised to 4 means how to write 4 delta A over A plus B raised to 1 by 3 delta B over B plus C raised to nothing means C raised to nothing means 1. So delta C over C plus 3 by 2 delta D over D. Is it clear? Now tell me which is the right answer here. So delta Z over Z equal to 4 delta A over A plus 1 by 3 delta B over B plus delta C over C plus 3 by 2 delta D over D means option B is right. Question number 55. If percentage error in A, B and C are small a, small b and small c respectively, then total percentage error in the product ABC is A, B, C. Right? These are the given quantities. These are having error. Error is how much? Small a, small b, small c. We have to find the product. Remember, percentage error in product ABC, that we have to calculate. In a product, percentage errors are always added up, because you can remember Z equal to X into Y, delta Z over Z equal to delta X over X plus delta Y over Y. Here we are going to add the percentage error in multiplication as well as division. So when we add the error, so A, B, C means we can write delta Z over Z equal to A plus B plus C. These are the error in the given quantity capital ABC. So we have to add the values A plus B plus C. So option B is right. 56th question. Length of the one rod is L1 equal to 3.323 centimeter and the other is L2 equal to 3.321 centimeter. Both rods were measured with one measuring instrument with least count 0.001 centimeter. Then L1 minus L2 is. Here L1 value is given 3.323 centimeter. L2 value is given 3.321 centimeter. Least count is given 0.001 centimeter. We have to find L1 minus L2. This is error in subtraction. See here, error in subtraction means we can write error in subtraction, that is Z equal to X minus Y, delta Z equal to delta X plus delta Y. You can remember these equations. Here I am going to write L1 minus L2. L1 minus L2 is equal to 3.323 plus or minus, least count is how much? 0.001 centimeter minus L2 value 3.321 plus or minus 0.001 centimeter, because least count of the instrument is given. Now L1 minus L2, 3.323 minus 3.321, we got the value 0.002 centimeter. Similarly, we have to find error in subtraction. Delta Z equal to delta X plus delta Y. That is here delta X, this is delta Y. Add this value 0.001 plus 0.001. We will get 0.002 centimeter. Then how to write the final answer? The final answer L1 minus L2 is equal to 0.002 plus or minus 0.002 centimeter. So 0.002 plus or minus 0.002 centimeter means option C is right. 57th question. What is the fractional error in G? Calculated from the equation T equal to 2 pi root of L by G. Given fraction error in T and 1 and L. Given fractional error in T and L are plus or minus X and plus or minus Y. The given equation is T equal to 2 pi root of L divided by G. We have to find a fractional error in G. Squaring on both sides, T square equal to 4 pi square L divided by G. Or we can write G equal to 4 pi square L divided by T square. Here 4 pi square, this is constant. Leave it. Remaining is what? G equal to L divided by T square. So we can find error in G. Delta G over G is equal to delta L over L plus, this is error in power, 2 into delta T over T, which is equal to delta L over L. It is already given T and L. Fractional error in T and L are X and Y. L is having the error Y plus 2 keep as it is. T is having the error X. It is given Y plus 2X. This is the fractional error in G. Y plus 2X or 2X plus Y. 2X plus Y means option C is correct. 58th question. N divisions on the main scale of a vernier caliper coincide with N plus 1 divisions on the vernier scale. If each division of the main scale is A units, then least count of the instrument is. So here I am going to write number of divisions on main scale. How many divisions are there on main scale? It is given N. Similarly, number of divisions on vernier scale. How many divisions are there on vernier scale? It is given N plus 1. Then each division of main scale is how much? A. So we can write size of main scale. Size of main scale division is equal to, it is given A units. Now we have to find size of vernier scale. Let size of vernier scale division be, let us take it as B. Main scale is having A, vernier scale size is, let us take it as B. Then we can write, then we have size of main scale into number of divisions, A into N. Similarly, size of vernier scale into number of divisions, B into N plus 1. We want B value, so we can write A into N divided by N plus 1. Is it clear? Then least count is what? Least count means very smallest value. We have to find least count. So least count means we can write least count equal to A minus B. Means Size of vernier scale division minus size of main scale division. So subtract these two values. Least count equal to A value is how much? Let us take A minus B means what here? A into N divided by N plus 1. Or we can write LC equal to A we can take outside 1 minus N divided by N plus 1. Take LCM, A keep as it is, N plus 1 minus N divided by N plus 1. Or we can write N minus N will get cancelled, A divided by N plus 1. So this is the least count of the instrument. LC equal to how much? A divided by N plus 1. So option D is right.